Hello, welcome to Lesson 1, Radio Frequency Measurement Fundamentals, Hardware. So what we're going to cover in this lesson is RF sources, radio frequency sources, RF receivers, RF connectors and RF transmission lines. So, radio frequency source and receiver. Normally these days you use something called a vector network analyzer or a VNA. This actually produces and measures the RF signal, and it measures it both in magnitude and in phase. So these machines work over different frequencies, a massive range of frequencies from megahertz to gigahertz. You can have multiple ports available, so you can measure more than one source at a time. Instead of a VNA, you can use a signal generator to produce a signal and a network analyzer to analyse the signal. Particularly if you're using an old system, this is quite often the case before they were kind of integrated, or if your systems are very far apart, say your transmitter and your receiver are a long way apart, you might actually choose to use separate items and actually then synchronise the signal. There's lots of different makes of network analyzers. Anritsu, Keysight, or depending on how old the equipment is, it could be a HP, it could be an Agilent. It's all the same thing. It's the same company that's been taken over multiple times, or Roden Schwartz. They're all really good. They have slightly different interfaces, slightly different key features. It makes no difference. It will probably be down to just what your company normally uses. I do have to give a slight shout out to Anritsu because they have the best merchandise, because they give you bears, the Anritsu logo, and their slogan, the best in test, on the back. So they win on the merchandise front. But from actual performance of the machine, they're all as good as the next one. So, transmission lines. Transmission line, it just literally means something that takes your RF signal from here to here. It's a transmission and it happens to be normally a line. So, we're not into, fanciful naming of stuff. Most common one is a coaxial cable. So this is a cable with a central metal core. You've got some dielectric insulator around it, and then a shield and a plastic jacket. They look like this. They are that exciting. They do just literally look like a large piece of wire. If you look closer, you can see there's actually webbing on the outside of that allows you to flex and to move. So this is a flexible coaxial cable. You can get rigid ones, you can get semi-rigid ones, so you would bend it and it would stay there. Depends on what purpose you need. Another common transmission line is a waveguide, which is literally a tube of metal. It can be rectangular, it can be circular, depending on whether you're using linear or circular polarization. And you have different sizes for different frequencies. They go from tiny kind of watchmaking size to corridors to motorway tunnels. So it depends on the frequency that you're using. The connectors you use most commonly are an SMA connector. So whatever you buy will come with a dust shield, which you need to keep on to protect it from dust. Take the shield off, and this is an SMA connector. And you can see the pin in the centre is your coaxial middle centre. You've got the shielding around the outside, and you just screw that into place. N-type, BNC, exactly the same idea, just slightly bigger, tend to be used for different frequencies and different powers. So what connector you use doesn't matter as long as it's suitable for your power and your frequency requirements. So, conclusions, what have we learned? VNAs, vector network analyzers, are used to test radio frequency hardware. Transmission lines transmit the signal from place to place. Common ones are coaxial cables, waveguides. SMAs are probably the most common type of connector, and got to be really careful about your frequency range. Make sure whatever you're using is suitable for that frequency range. So the next chapter is going to look at the setup of RF measurements and what results you take from them.